Okay. So one of the very positive things, in my view, that the CRA has been involved in is the development of a series of examples for the ICT, the information communications and telecommunications sectors. We talked about 3 of those examples during our prior meeting, which included some general guidelines and what I felt were relatively complete examples to show what could potentially be SR&ED. One of the key areas is that, and we talked about it in the dispute resolution, is that, we will talk about it in dispute resolution, is that there's been a number of objections. I'm going to talk about that as my last presentation here. There's been a number of objections that have been growing, and a lot of them, probably a third to 40%, are related to the software and communication fields. So what we've done here is we've taken the software example that deals with blockchain. So it's an example of a blockchain technology where people are using cryptocurrencies. So it was a popular development area until a big crash within the last year. But an area where I guess they've been receiving claims and they've been able to provide some examples of the types of issues that would pop up. So what I'll do is I'll give a quick overview here of what this relatively complicated example contains, discuss the paper itself briefly, because the paper went through 3 examples, and I'm really, based on our time constraints here, going to focus on the 3rd example, which was the part that was eligible. The paper itself is at the CRA website, and it will outline 2 examples as a lead-in as to what was probably not eligible SR&ED, but was interesting product development. And one of the key things that it will talk about is the methodologies. Is there uncertainty on the methodology in order to achieve the end solution or not? So one of the things that I like to look at is what kind of benchmarking did the claimant do before they started the process? And this is usually a combination of objectives and uncertainties or key variables. So the way we do our keyword search is we say, well, we're going to see if anyone had a blockchain method to achieve certain energy efficiencies or scalability or reduce redundant operations or any of the types of objectives that the CRA provided in its example and that we've in turn tried to quantify for our example. So what we've said is, well, we have various objectives. Maybe we want energy efficiency. We're at 15 kilowatts an hour and we want to go lower, or we end up higher. Those will be, again, results that we can go back to and explain why did that happen? What did we do that caused these problems? The fact that we looked at different articles or competitive products, and more importantly, the methods using those products, is critically important then to determine whether the hypothesis that we're looking at is an advancement of technology or just using existing technology. So what we're told that the main hypothesis in this project is an ability to use something called a back-off mechanism. So there's different mechanisms that blockchains use to model the data. And the back-off mechanism is one such mechanism that was used in different environments that we hypothesize, or the developer hypothesized, could be useful here to achieve these goals. Okay? Then they identify a number of variables that they need to experiment with or that they're uncertain about in order to achieve the objectives. So they talk about things like the dynamicity, the number of joins and leaves that are there, the neighborhood size and definition. So how you do that will affect how the quality of the mechanism performance. The number of nodes, the propagation radius, and whether we're using a single point or multiple blockchain channels. So these are just 5 of several variables that were listed in the description and hypothesized about within the development. Okay, so what this does is a key criteria summary. It allows a reviewer or a manager to come in and ask themselves certain questions. Did we benchmark standard practice? If this area is blank, again, there's probably a problem in the description. If we don't have quantifiable objectives, again, we may have an eligible project, but the tax courts have reiterated since the 1980s that systematic investigation involves extremely accurate measurement and analysis of those measurements. They go on so far as to say that without such measurement and analysis, systematic investigation cannot exist. And so again, the failure to quantify objectives and results, again, is missing an opportunity to provide those extremely accurate measurements within the description to convince the reviewer that the work is in fact eligible. One of the other key things that we're talking about doing here is looking at methods. So how did they look at the project? And I think this is something that the CRA's done good here. They talked about, that they analyzed different alternatives. Maybe they tried different alternatives. Maybe they built different prototypes. Some parameters like the total number of lines of code that you have been written versus scrapped could be eligible, and compare that to the total man hours, right? So you may have 1 million lines of code. You may have 10 million lines of code that were scrapped. Again, that doesn't tell you exactly that the time and cost is reasonable. Some people write code faster than others, but the reality is that it's a representative benchmark that can help someone skilled in the art determine whether the time and cost is reasonable. Okay, so that's a quick overview of the consensus mechanism, which is, again, the third of the projects. And now we're going to talk about a few of the specifics within the project itself. So as we said, this project's based on the CRA description or paper that's released in October 2018. Now this paper is fairly long. I believe it's over 50 pages. And the description that we're talking about itself is spread over a number of pages. So again, we've tried to condense what we think are the most significant pieces of information to provide a concise summary that we can use to show people this could be eligible. And ideally, our hope is to help people in the software industry self-assess a claim, that if they're doing similar types of work, they can relate to these types of issues and say, no, I understand how and why I want to structure this project now, and the issues that I should focus on, which are the methods to achieve the results, rather than that the results can be achieved or not. Okay, so what we were told in the fact scenario here is that the company is specialized in social media. It's not technically a software development company, but they wanted to use a new cryptocurrency tool within their website to reward users of their products. Okay, so they say that the existing proof of work consensus mechanism guarantees a fair distribution, and that they may want to enhance this mechanism using mining pools as an alternative in order to achieve these objectives. So they've talked about the existing mechanism that would be standard practice, and now they're talking about changing it by augmenting it with the use of mining pools. So again, these would be the kinds of documentation you would look for prior art. Has anyone else ever used mining pools for improvements of this mechanism? And if so, what did they do, and what are we doing that's different? They have also provided alternative methods, such as a proof of stake method and other methods that could also work. But then they go in and they talk about the shortcomings of that method, the pros and cons, and why it may not work. Okay. When they talk about providing at least 30% reduction in energy consumption, again, what we've done is take that metric that they have and just try to give some examples of objectives, whether we want 30%, 50%, 80%. We want to quantify something there and then compare it to our objectives. Some of the other important things are to outline the backgrounds of the key employees. Again, it wasn't done in the CRA example that I remember, but it would be something that would be useful to look at within the claim itself. Software is, again, an area where often people have a software development background, but often people from other fields of technology come in and can contribute as well. So a very interesting area. Okay, so outlining their uncertainties themselves, what they found is the backup mechanism, which is a standard mechanism used in wireless LANs, was a good candidate. They talk about that it uses random timers to grant access to reduce the collision rate. And then basically how that would work to reduce network congestion. Their hypothesis or their idea is to transpose this mechanism or tool into a blockchain environment. Okay? They're going to use the collisions to duplicate the validations, and then they're going to try to apply the back-off mechanism. They're saying that it can't be directly applied, so they're showing the problems of applying direct standard practice because this mechanism that they have is designed to share access to one channel, where in blockchain you have numerous channels or validations occurring simultaneously. Okay? So they're basically saying that they've taken the mechanism or the method and shown why there's uncertainty on applying that particular mechanism as it stands to achieving their objectives. They then talk about some of the hypotheses that they have in order to perhaps make that work. So we talked about the number of nodes, dynamicity, the neighborhood size and definition, single versus multiple channels, and the propagation radius. Okay? What we then do is talk about how we've benchmarked our standard practice, how many alternatives we looked at, and specifically what we did. So again, they've given some fairly good evidence here as to how they tested the back-off mechanism, that they created variants of it. So they didn't just plug it in, they tried it, they created variants of it. They then looked at how it worked with the LANs, with the wireless LANs, to do different sensing types of processes. They looked at the blockchain topology and found that there was no way for a node to get a sense about the activity of the other nodes. So again, they're identifying the uncertainties and the new variables that they're bringing up to deal with this. Okay? So they talk about a region to create a region of miners to allow them to look at localized mining activities. So usually in large data, they do something like that, where they'll try to characterize or classify groups of information to allow it to be searched more quickly. And then that in turn allowed them to determine the propagation of the data for the collisions. Okay? So they talk about different mechanisms, the fairness of work mechanism versus the other ones. They talk about identifying parameters as to the number of nodes, degree of dynamicity, and the peer-to-peer networks in order to validate the network size. So again, what you'd want to do is go through these with someone who's doing similar types of work and give these as examples of the kinds of things that even if they're not doing something identical, if they're doing something similar, this could provide a basis for them to self-assess. Okay? They talk about performance metrics. So this is really important, reducing the number of mining operations, things like that. So wherever we're talking about measuring stuff, that's a good opportunity for us to give objectives and then results and conclusions. Were we able to reduce the operations? By what percentage, and how did that compare to expectations versus the other types of methods that we're looking at? Okay. They talk about simulation results. So again, where you're doing simulations or multiple simulations, that's a good or a strong evidence of technological uncertainty and investigation. Okay. What we then do is look at the results themselves. Do we have any results? And if so, how do they compare with expectations? So if our energy efficiency is at 71% of the goal, that's good. Maybe we can explain why we didn't get it. Where we've exceeded goals, again, how did the variables perform in excess of our expectation? So again, the further we are from our expectations, usually that leads us to conclusions to try to explain how that worked. So they've said that the conclusions of the advancement are that the principles of the back-off mechanisms for media access controls can be used to create that. That dynamic incidences can run in parallel. So that was something that they learned. That they can reduce the amount of redundant operations by 40%, which is again a result by using different mechanisms, the FOW versus the POW and POS mechanisms, and that the FOW mechanism has scalability issues, so that we may again have more work looking at different mechanisms for different types of data. And again, the CRA is saying that at the end of the day, what this paper does that I think is positive is it says that this third project would be indicative of an eligible project. Many of the other project examples that they provided before brought up issues but didn't really state whether a project would be likely eligible or not. Again, they were more just discussion papers. This one goes on to say that this one is likely eligible for the methods that we talked about. What I've done for people that are interested is I've taken the information that we've explained in that project example and showed how it would generally load up into the T6s1 description and how it would read in there. So that basically the square and triangle, the objectives and uncertainties would go in the first box. What is it, the advancement we're trying to achieve? Sorry, the objectives would go in the first box. The technological uncertainties would also follow that. And then the actual work that you perform, the activities, would go into the second box. The final box, the conclusions, represent your technological advancement. So generally, we put the results and conclusions in the final box to close things off. One of the things that we also noticed is that when you write descriptions outside of it, you may import stuff and find that certain things get cut off. So based on the word limits of the form, if we were to upload that description directly, there would be information that didn't make it into the description. And ideally, when you're doing that, and I guess the method that you're going to use for doing that should make sure that the most relevant information is there. So you may want to copy paste or cut and paste something else out. If in fact something is as important as your benchmarking sources was getting cut off, maybe we can replace something else in there. Okay. On that basis, I will stop and leave it open for discussion. And I have one more brief presentation to talk about notices of objections before we lead into the case studies. So I'll let you take over here, Liz.